Activity, we learned that a polygon is going to be a closed figure that is made up of 3 or more line segments that intersect only at their endpoints. So here they're giving us 3 examples of polygons. So once again, if you look, they all have straight lines, okay, no curved sides. They all are an enclosed figure. Okay, so when we compare that to non-polygons, well, what eliminates them? This is enclosed, but we have curved lines. So that eliminates it from being a polygon. Once again, this one is also enclosed, but does not have straight edges, so that also is no longer a polygon. The next one looks like it is enclosed, which it is. It also has straight sides, but what eliminates it from being a polygon is the fact that it's actually 2 triangles. So it's really 2 polygons. Okay, so it has to, you can't have where there's that closing there. It actually created 2 polygons. So in and of itself, just being a polygon would be eliminated out. It would actually be 2 polygons that are just attached to each other. Okay, we also reviewed in our activity what a convex polygon is and a concave. And convex is where you're going to have all of your vertices actually point outward. A concave polygon is going to cave in on at least one of the sides and have at least one vertex that is going to point inward. So for example, this would be a convex because all of them point out. These 2 would be considered concave because see how this points in towards the inner part or caves in? And same thing here. This vertex caves in or points. So this would be a concave because it caves in, or those 2 would be considered concave polygons. So we're going to actually be working with those 2 concepts that we did in our activity just to kind of review through the information that we did in our activity for this lesson. Okay, so here's our first example. It says find the sum of the angle measures of each polygon and identify if it is a concave or a convex polygon. So what we need to remember is from yesterday, we found out that if we knew the number of sides, we could subtract off 2 and then multiply by 180. So here I have a 3-sided figure. So if I took 3 minus 2, that gives me 1, and then took that times the 180, it gives me 180 degrees, which we already know that about a triangle, so we wouldn't need to use that formula to figure that out. We know that a triangle equals 180 degrees. This formula is going to help us go through and actually work with some larger sized, or larger in number sides polygons. Okay, so let's go ahead and look at this next one. When we count the number of sides, now I'm one that likes to go through and actually touch each side, so I tend to mark it 1, 2, 3, 4, 5. So there's 5 sides. So our formula is we're going to take our number of sides, which was 5, minus 2. Okay, so when we do that, we get 3, and then we're going to take that answer times 180. So if I take 3 times 180, that gives me 540 degrees. Okay, the other thing that we want to identify in practice is this a concave or a convex polygon? So when we look at each of the corners, they're all pointing out. None of them are pointing inward or caving in, so this would be a convex. Okay, as soon as you have one of your sides cave in, then it's considered concave. Okay, so we have a 4-sided figure, so if we do 4 minus 2, and if you want to do the triangle part, that's fine. It's just that concept is not always going to work or be easy to use. But we know there's 4 sides. And if we subtract off 2, because that's our formula, so 4 minus 2 gives us 2 sides. So now we're going to take 2 times the 180. 2 times 180 gives me 360 degrees. So this is a 360 degree angle or degree polygon. Okay, so now if we go through and decide if it's concave or convex, looking at the vertices, they all point out. All of them point out. So this would be convex. Okay, as soon as you have one that caves in, then it's considered concave. Okay, so here, this one's got lots of sides. So if we go through and we mark each of the sides, I like to mark them because I'm always afraid that I'm going to miss one of them. So 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon, 8 sides. So our formula is to take our number of sides, 8 minus 2, which is going to give us 6. And then we're going to take that times 180 because that means there's 6 triangles that make that up. So let's see, 6 times 180. When we do that, we get 1,080 degrees. So it's a 1,080 degree figure. And all of the vertices point outward. So this would be, again, a convex polygon. Okay, so I want you to try these next two. Oops, wrong one. Okay, so go ahead, pause your video, and work your way through this one. I want you to find how many degrees are in that polygon using our formula of the number of sides minus 2, and then taking that answer times 180. And then I also want you to identify if it's considered a convex or a concave. So go ahead and pause your video and you'll work your way through these two, and then check back to see your answer. Okay, so on this first one, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 2 is going to tell us our number of triangles, which is 7. So we'll take 7 times 180. And when we do that, we get 1,260 degrees. And all of the corners point out. So this would be a convex. Okay. On our next one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So 10 minus 2 is going to give us 8 triangles that would make that up. And then we're going to take that times 180. So 8 times 180 gives us 1,440 degrees. And here we have where it caves in on multiple sides. So this would be a concave. Okay, so that's working with that formula of S equals our number of sides, or N as what they often use. I noticed on STAR that they tend to give you that formula. So your number of sides minus 2, which tells you how many triangles are in there, and then we take that times 180.